Okay, welcome back. In this video, we are going to look at 9router and dive into some code. We looked at issues for this one, and we even looked at some code last time. And so this time I want to not just talk through some of the things, but I want to show some of the things. I believe we looked at a few files, but I think we determined that usage DB had a lot of opportunities in it. And I think this is the one. Yeah, I think this is the one because it's emitting and then, yeah, track pending request. Okay. So, yeah, this is the one. Close this out. So, this is the file. And the more I look at this, the more I'm thinking that this is actually generated code. Because almost every function is doing defensive checks, defensive checks. And there's, well, what is this? Path.join, 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 path.join. Yeah. So, um, anyway, uh, let's, let's take a look. Let's just start here with this get app name. This could flow better. Um, that's actually a good point. So there's a couple things we could do here. We could we could refactor this, right? We could we definitely need to make a try catch function because when you are constantly repeating yourself by just having these procedural constructs everywhere in your code or in your system, it's repetitive, it's noise, it adds to your cognitive load when you're trying to read through the code and understand what's going on, especially in situations where you're under a tight deadline, you're under pressure, and you're trying to identify a production issue and fix it. When you're looking at production code and you're trying to identify an issue and you're trying to fix it, the last thing you want to be doing is be looking at code like this. This is fine because it's not fine, but this is a small function. There's not a whole lot going on, but when you start to see this same sort of style of coding in larger functions, see, we're getting larger here. Um, we're getting larger in this get user data, and it's just continuing to go, right? Same style, we're just continuing to go. Allocation on the outside, right? Um, like, what are we even doing? So we're allocating this instance, but this is being allocated in, is it in this function? No, it's not. It's not in this function. It's just hanging out in this file. Got it. Which means it's probably going to be used in other functions, but that's my point, is there's just no rhyme or reason. That's my point, is this style of coding. As I mentioned before, we could use just straight up composition. We could create functions and just compose them and create better control flow that way, and that would be fine. We could use a pipe, and we could use Lambda, or we could define our own if we have an issue with bringing in a third-party library in our projects. Sometimes I get that, but for the most part, just do it. Like, just bring it in. It's not that big a deal. It's not that heavy. You're only bringing in the functions that you're using. You're not bringing in the whole library. So just bring in the things that you need to use and make your life easier. That's my 2 cents on that. Or yeah. So but Lambda has this, right? So compose. It's a function that takes, it's a higher order function that takes a number of functions and then combines all those functions into one function and just runs them from right to left. So in this case, we've got compose. It's got a function toUpper, and it's got a function called classy greeting, and it's going to run classy greeting first, then toUpper, and that's why you get this output here. So that's compose, right to left. And then pipe is the same as compose, but in the opposite direction. So pipe runs from left to right instead of right to left. So this particular function takes the power function, the negate function, and the increment function, runs them from left to right, and produces this value here. So yes, we could use that, and that would clean this up and make this flow better than just what we currently have, which is line, 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 try catch, right? Taking it a step further than just a string of functions being ran in a compose or in a pipe is using a functor, right? And this is where we sort of dive a little bit deeper into the functional programming realm. When we talk about control flow, this is where functors play a massive role in cleaning up a lot of repetitive code, a lot of noisy code, and making it flow better. So what do I mean by that? Let's open up Run.js, and let's just talk about functors for a second. So what is a functor? Just relax. It's not that serious. Functors come from category theory. You don't need to know category theory to understand functors because you're already using functors in your everyday JavaScript code. The best way that I can maybe describe it is with a functor that you use all the time that you're already used to, which is the array. An array is a poor man's functor, right? So if I just create an array here, box, right? Taking a step back and just thinking about the functor definition for a second. What is a functor? A functor is a container or a box in this case, but it's a container that has a value in it, or really it's just a container that would contain a value. But more importantly, the container has a map method on it. okay? And it's subtle, but it's extremely powerful, just like map is powerful on arrays. Um, a functor, you can think of it as, there's a lot of ways to think about it. You can think about it as a box, like I said, that has a value. You can think about it as a jar that has a lid on it. You take the lid off the jar, you put a value in the jar, and then you put the lid back on. So now you have a functor that's holding the value 1. But then you want to do something with that data. So then you take the lid off, you take a function, you put it in the jar, and the function gets applied to the value in the jar, producing a new value, put the lid back on the jar, and now you have a functor, same functor, but new value inside of it. And you just keep mapping and you just keep applying functions to the value inside the container or inside the jar. That's the simplest way, or that's just kind of the simplest way that I can explain it, but let's look at it more here. So I have a box, and I'm going to put, like I said, I'm just going to put a 1 in it. Okay? And now I'm just going to map, because I can do that, right? And I'm just going to increment this by 1, right? So now I have a box of 2. I can continue to map this, no problem, right? I can take that value, I can apply another function to it, and this time I can, do that, and then I can just continue to do additional arithmetic. I can do something different, like put this in a string, right? Um, I can now get the length of that string, right? So this is how we wrangle this noise, this type of control flow, that it's still composition to a very rudimentary degree, but it's composing this line with this line, because you're computing a value and then that value is being used in the next line. But there's state, right? Every time you create this, you're creating state and then you're creating more state that's derived from the previous state. And in a larger function with a lot more things going on, that's a lot more to kind of wrap your head around. What is the state of things? And as I create more state, I'm just creating more things, and I'm making it that much more difficult to reason about. When you have it this way, all you can do is map. There's nothing else you can do. Now, yes, of course, if I, did this, it's going to apply that to everything. But what I want you to focus on is just one value. A functor is like an array, but just one value. It doesn't hold a collection of things. It just holds one thing. And once this particular function is applied, it's not in the state anymore. It's gone, and it moves on to the next function and applies that value, and then it's gone. So all you can do is map here, right? There's no room for me to come in here and tweak something, or use something in an unintended way, introducing subtle bugs. There's nothing for me to fiddle with. I have to create a function, and I have to apply it, and I have to map. And that's great, because it keeps me at a higher level of thinking. I know that every function that I give it is a function that I can test. I know it's a function I can reason about, because it's just relating inputs and outputs, right? And look at it, it's flowing better, right? This is way better than something like this. So, yeah, that's a functor. We're going to create our own because there's many functors in category theory. Um, and they're all used in combination to help with control flow, to help with things like error handling, dealing with things like state um, or IO, and all kinds of things. But we're just going to keep it simple for now, just so you can get a better idea of what I mean by flow. So let's start by, I'm just going to bring some of this in. I think I need, yeah, I need path for this get app name function. I need path, I need fs. I don't need OS, but I'll just because it's easy to copy, I'll just bring it all in. Okay, let's just pull this down a bit so we can see it. I don't need OS. I don't like I don't like semicolons everywhere. So let me just, for my own sanity, kind of get rid of some of this stuff. Okay. All right. So okay. So I think what we're gonna need is, it's got an issue with this import because I don't have that. So I'm gonna have to create import that's a keyword. I'll just add a T and then change this to that. Okay. And then this will be an object. It'll have a meta property on it. And then that will be another one. And then we need a URL here, I think. Yeah. And that's just going to be a string. Okay, so we can collapse this down for now and look and see what we got here. Okay, so we have path, we have our function, file URL to path, and then is cloud. So if I run this, I guess I should, let me run this. Let's see what we get. We get 9router. Why do we get 9router? Because we don't have cache, because isCloud is looking at cache to see if it's undefined or if it's an object. We don't have that, so it's just going to return 9router. If I comment this out, now we get to invalid URL. That's probably this because it's blank. So what is it looking for? So once we get a URL, it's looking for a package.json. And then it's pulling that in, and then it's parsing it. And then it's looking for, okay, it's looking for a config property. If a config is there, then it's going to look for the app name and grab that. Otherwise, it's just going to return 9router. Okay. So let's just get this working. To do that, I'm going to need a package.json file. I guess I can grab, let's do this. API sauce is what we were looking at last. I can just copy that and use that. Yeah, it's in the YouTube. I moved things around recently. YouTube functional programming folder, and then we can, API sauce should have a package.json. It does. So let's come back up here and let's just copy the package.json to the current directory and clear some of this out, and then let's just make sure the file is there. It's there. And then I need the path for this directory, so the working directory. Grab this. Whoops. Grab this. And make this the URL. Okay. File URL to path. So because this is just a path, we're not trying to let's just do API sauce. We're not trying to convert a URL. It's not a URL. We could make it a URL so that it converts to something that looks like this, but in the interest of time, I'm gonna modify this code slightly. I'm gonna take this call out and then just have the path be that. Okay, so now this is giving us a directory name. This is question is, okay, so let's just make sure that this is happening. But before we do that, I want to give myself, I don't want to be typing out console logs everywhere. I'd rather just shorthand that. So let me just do this. Okay, and let's just make sure that we're getting what we think we're getting. So I don't need to, well, yeah, okay, I guess we can try to log the directory name. Okay, so we're getting the YouTube directory. That's cool. Let's log the root package path. Okay, so we're getting that. And then it's just going to try to read it here. And okay, so there's no configure app name in the package.json, I'm guessing. So instead of catting that, let's just do this. We don't need to open the editor for this. Okay. And there's no config and app name in here. So that's why scripts, prettier, lint types, releases. Yeah, there's no config or app name in here, so that's why it's just returning 9router, which is fine. That's to be expected. But let's go back up here and let's just add it. Okay. And this is a good place to add it right here. Config. And then what was it? Config and then app name like this. And then we'll just do API sauce just to have something different. And then we'll do add that so it's not complaining and yelling at us. Save that, and now we need to rerun this function, but in order to do that, we need to just trigger the editor. So I'm just going to do this to trigger it, and now we get API sauce back. Okay, cool. All right, so this is working. I just commented this out, okay, and I took away the this guy right here. So I just commented out two things, but ultimately this code is relatively the same. All right, so with that, now we can start to look at how we can improve the flow of this by introducing a functor. Okay, so let me just create a functor. Do you want to do that first? Yeah, let's do that first. Let's do, where do I put it? We don't need this. So let's do this. Const, we'll call the functor box for now. And then the functor is going to take a value. And then I want the functor to not be an array. I want it to be an object. And that object needs to have a map method on it or a map function, just like the array. But, because it's an object and I'm returning in an arrow function, I got to do this. Map is going to take a function like it always does, and it's just going to apply the function to the value, to the x, right? But it still needs to be a container at the end of the day. We need to be always return a container. Return the box, right? In this case, we're not returning the array with the value in it. We're returning a box with the value in it, like this. So now, I also want to add to this functor an inspect function or method that just allows us to see what the value to see the box so that I'm not logging it every time. So let's do this. Let's do box and then whatever the value is inside the box at the present time. Okay, I think we're good here. Let's just go with that for now. All right, and what we'll do is we'll rename this because we're just going to rewrite this. And let's write it the way it should be written. All right, so const get app name. Now, technically, this value, since this is the first thing we're doing, well, technically this is the first thing we're doing, but we're just ignoring that for a second. The first thing we're doing is we're actually computing this value and starting to work with it. I think that it shouldn't be closed over like this. I think it should just come in here, but we'll just leave that for now. And we'll just put that to the side for now. Okay. So we have a box and we want to put our value in the box. So we're just going to put in our import dot, our URL basically, right? We're putting that in the box. So now we can see down here, and this is what I love about run.js, we now have a box with a value in it. What's our value? It's the path, right? It's our URL from this import. Great. So now that our value is in the box, we just map. That's all we do. And the function that we're mapping is this path.directory name here, right? So we're taking the URL that we have and we're just computing path.directory name with the URL, right? And we can clean this up even further. Remember what I was saying in a previous video about the algebra here, and that this and this cancel out. These are variables that cancel each other out. So really, it's just this, right? And then what are you mapping? You're mapping, the next thing you're mapping is path.resolve. So we're getting back a directory name, so we can just say dir name here. And then we can do path.resolve and dir name along with package.json. Right. Okay. So now we still have our package. We still have our URL with our package now, right? So now our directory name has the package on it. That's great. This is kind of updating for us in real time. Map. The next thing we want to do is this. Okay. So, as I said, we don't want to constantly be writing these procedural structures everywhere in our system. Ideally, you would pull this out or pull this in and you would just use this, a try catch function that takes, it's a higher order function that takes two functions, a try function and a catch function. Okay, it's going to run the try function. As long as there's no errors, it's going to return whatever that function returns. It's going to, if it does throw an error, then it's going to run the catch function, passing that error to the catch function, and run that function and return whatever that function returns. But again, if you don't want to pull in third-party libraries, make your own. And we've got a log here. Let's just make our own try catch. All right, so our try catch is going to be a function that takes a trier and a catcher. Okay, and then it's going to basically do what try catch does, right? We write the procedural construct. We write that here. That's fine, but we only write it once. That's the key. We write it once here. And then we just run our trier. There's better ways to do this that Ramda implements, but I'm just showing you here that you could do it. Trier, and as long as there's no error, it's just going to return whatever the trier function returns. The catcher then is going to be called catcher with the error. We're just going to pass in the error to the catcher and then return whatever that's going to return. All right. So now, I don't. Do I need this? I may not need this. Let's just try it without it first. I may not need those returns in there. But let's just try that. High level description, right? And then we can just put this in here just to kind of look and see what it looks like. We can always refine it, but the next thing we want to do is we want to get access to our root package path is what it's being called. And here we want to do our try catch. And our try catch, we're just going to run this function. This function is going to take a trier function. And the trier function that we want to run is it's basically this here. This is our try. We can literally just take this and put this in here. All right. All right. So that's going to be our try. Yep, root package, fs, package, and then our catcher function is very simple, right? It's just 9router. We're actually going to ignore the error that comes through here. And we could do an underscore, we could do an underscore E to represent the error, that we're ignoring the error, and we're just going to return 9router. At this point, box is undefined. So why is box undefined? So we're passing in a function, the trier, and it is being executed. Let's just try adding the return here. Yeah, so I do need the returns. My bad. Okay. So now we're getting back the result of the try, which doesn't throw any errors, right? But if we change the, if we change this, so like if we were to, we can collapse this back down. If we were to expand this and say, oh, well, you know, give it a path that's broken and rerun this, we're still getting API sauce. Oh, that's because it's only using this. So we need to change something in here like this. There. So now when we do a read file sync, this is actually throwing an error because there's no path with the S on it. And sorry, there's no path with the S on it. This is having an issue in throwing. But the way that our function works is that this function now gets called and 9router gets returned. But if I come back and I change this and I make the path good, now we see we get our API sauce. So this is read fine, we're parsing it fine, we're getting the app name out, and that's API sauce. So, but the final thing, so just before I move on here and kind of finish this up, just notice the flow. I just want you to notice the flow. We're mapping. We could easily make this is kind of noisy, right? We could easily make this like, we could easily come in and have a the trier be that, right? We could just take this out like this and have this be our trier, right? We could have our catcher be, whoops, can have our catcher be 9router router like this, right? So we could define those elsewhere. These are functions that we can reason about and we can test, and these are functions that are just that much more ready for production. Now you can tighten this up and just sort of say trier here, right? And catcher here. Okay. And I gotta spell catcher right. Okay, and now you have 9router. We should have API sauce here, not 9router. Okay, so we have API sauce. Let's try that one more time, but I think you understand what I'm saying. Basically, we're just extracting the function here, and this is catcher. Our catcher is just 9router. And then we should be able to, oh, sorry, this takes an error, but we need to ignore that. And then our try catch now becomes our trier and our catcher. And now we're getting 9router, which is interesting. To figure that out, but log, so package is not here. We're not getting anything for package. Nothing's happening. We still have a log. So why isn't... Ah. Yes, that makes sense. So we need to pass in to our trier here the root package path. That's what I forgot to do. Root package path. Okay, so now we're getting the log here, and we're still getting 9router. So let's just look at the package again. We're getting the package. Make sure config app name API sauce is there. Okay. So why is it returning? There. Okay. So I needed to kind of partially apply. Yeah. So this Ramda handles all of this for you, but so basically this needed to go on the outside. So the way that this was defined in a very simplistic way is just running a function, but I'm not passing anything in. So that just means that the value that I'm closing over needed, which is here, it needed to be defined on the outside. So I needed to pass it in and then have the function just run with nothing, because that's how it's defined. That's how I defined it up here. But I don't want you to get caught up in the details of all of that. Suffice to say that that's kind of the point here, is that we can, the real point is that we can clean this up by making it a function and calling it and getting API sauce when the trier function succeeds, and when it doesn't succeed, right, we get 9router. And that's the point. And you can see that this code flows a lot better. We've introduced a functor. We've introduced functions. Let me just check the time. Yeah, 44 minutes. I gotta wrap this up. So I just wanted to go over functors and explain how we can use functors to make our code flow a lot better. It doesn't have to be this way. And when you're looking at more and more functions that look like this, it's easier on the eyes. You're kept at a high level. You're always thinking about functions. And the last thing we need to do is not return a box. We need to take the value that we're looking for, which is the app name. The app name is not box API sauce. It's just API sauce, or it's 9router. So the last thing we need to do, and then I'll wrap this up, is just add, I'll do it up here, is just add a fold. And all this is going to do give us a function that we can apply to the value in the box. We're just going to apply the function, but we're not going to wrap it back up in the box like we did with map. We're just going to return the value. Okay, so now, the last thing we do is fold, right? And what are we folding? We're folding out, we're getting at this point we have the app name, right? And what are we doing with the app name? We're just returning it, right? Identity function. This is the identity function. If we had Ramda, if we were bringing in Ramda, we could just do this, and that would be the same thing, identity function, as app name, right? And so now we get API sauce, and then, like I said, if there's an error, we'll get 9router instead. Okay? So, really long-winded way of explaining functors and basically showing how we can take code that looks like this, which was probably generated, and clean it up and make it flow better like this. Okay? I'm going to stop it there, and I think in the next video, now that you have an idea of functors, now that you have an idea of composition, now we can actually come in here and start applying these techniques to this code base. And I will do that in the next video. So I will see you on the next one.